What's up guys, it's Simon Fiaz and today's video is on AQA level chemistry, properties of period 3 elements and the oxides. Question 1, questions about elements period 3, given the equation for reaction sodium with water. So 2Na solid plus 2H2O liquid to form 2NaOH aqueous plus H2 gaseous. Okay, why is it dangerous? The idea that reactants can shoot out of the tube. Given the equation for reaction phosphorus oxide with water, P4O10 plus 6H12 to form 4H3PO4, and a pH for this solution formed -1. So in terms of crystal structure and bonding, where silicon has a high melting point than phosphorus oxide, silicon dioxide is macromolecular. Strong covalent bonds needed to strong covalent bonds, hence a lot of energy needed to overcome those bonds, whereas P4O10 is molecular, meaning a simple covalent molecule, and therefore it's got weak van der Waals forces between molecules, and it's little to no energy needed to overcome those bonds. Given formulas is oxide. Oxide reacts with acid and a base, so therefore it's aluminium oxide, because that's the only one you study in period 3 elements in the oxide. And the thing about this is it's called amphoteric. That's a very special feature of it. Equation: Al2O3 plus 6 Al2O3 plus 3H2SO4 arrow Al2SO4 bracket 3 plus 3H2O. Al2O3 plus 3H2SO4 arrow Al2SO4 3 plus 3H2O. Given formula hydroxide element you use in medicine, magnesium hydroxide, so the formula. Identify the element from sodium chlorine that has a large atomic radius. Now I know, using this simple key fact, atomic radius decreases across the period. So decrease across period 3. So if I'm going from sodium to chlorine, that means chlorine is going to have the smallest atomic radius. One is the largest is sodium, because that's at the beginning. Draw across, show the second ionization energy of silicon, somewhere around about there. I would just recommend learning these graphs. You don't need to join them together. That's all I did. Then for element period 3 from sodium argon has a highest second ionization energy. Highest second ionization energy. Well, which one has the highest first? Which one? Now, if it asks me for this is what I'm thinking. I'm saying, okay, which one has the lowest first ionization energy? Because it's got the opposite of that. So if it has the lowest first ionization energy, therefore it's got the highest second ionization energy. So if I look at the one that's got the lowest, it's got to be sodium. Yeah, it's got to be sodium because it's got the largest atomic radius. So Sodium therefore has the lowest first ionization energy, therefore it's got the highest second ionization energy. Second ionization energy, we'll just do the opposite. So start off with a positive charge, and then I've got this Na2 plus gaseous plus E minus. So atomic radius decrease across period through sodium to chlorine. Number of protons increases / nuclear charge, and shielding is similar / electrons are being added to the same shell. Identify the element period 3 from sodium to chlorine that has a high electronegativity. What is the definition of electronegativity? First things first. Once you break down these questions, then it's a lot easier. Electronegativity is the ability of an atom to attract pair of electrons in a covalent bond. Electronegativity, ability of an atom to attract a pair of electrons in a covalent bond. That's electronegativity definition. So I know from sodium to chlorine, a trend you should memorize for elements period 3, atomic radius decreases to radius. I also know, therefore, first ionization energy increases. But that's not really relevant. This part's really relevant to me, because if the atomic radius decreases, electrons are closer, outer electrons are closer to the nucleus, and therefore it's going to have a strong attraction, so therefore it's going to have a high electronegativity to attract the pair of electrons in the covalent bond. So therefore the one with the highest electronegativity is going to be the one, aka with the smallest atomic radius. And if it asked me that, what would I say? I would say chlorine. So therefore the answer is chlorine. Phosphorus equation you just need to memorize. Sorry, I like this one. P4 plus 5O2. I think most people do this one. P4O10. Sodium, here's an oxygen. Na plus a half O2 to form Na2O. Therefore I need a 2 here as well. It doesn't ask me for state symbols, so I don't need to do it. 2Na, half O2 are Na2O. Observations, this is a difficult part, and I need to review them. Orange flame, white solid, orange flame and white solid. Phosphorus with oxygen, P4 plus 5O2, P4O10. Observation, white flame. It's been an increase in multiple from sodium oxide to magnesium oxide. It's a 2 marker, and it's got to be with a charge. So increased charge density on Mg2 plus ion compared to Na plus ion. Stronger ionic bonding, because there's a strong attraction between oppositely charged ions, so stronger ionic bonding. Saying multiple oxide silicon is much higher than that of the highest oxide of phosphorus. Wait, don't tell me, I've just done that question. And those are 2 different questions. So part C is in terms of crystal structure and bonding, where silicon has a high multiple phosphorus 5 oxide. In this case, Part D, explain the melting point of oxide of silicon much higher than same amount of marks, 3 marks. So again, you get 2 marks for this. You're stating silicon dioxide is macromolecular, or you can say giant covalent. Phosphorus is molecular / simple covalent molecule. The covalent, well, in this case it says much higher, while silicon is much higher, because the covalent bonds in silicon dioxide is much stronger than the intermolecular forces / the van der Waals forces in phosphorus. Describe a method for determining melting point samples that the result could obtain to use to evaluate its purity. Sample in suitable melting point apparatus, for example, capillary and oil bath. Heat gradually to establish melting point range. Lower melting point indicates low melting point / broad range of melting point indicates presence of impurities. Which element forms ionic oxide that can react with strong alkalis? Strong alkali is going to be aluminium oxide. One equation reaction of phosphorus and excess of oxygen. Again, the way I like to do it, P4 plus 5O2. From P4O10. Okay, and then the second part B, bit of a weird one, and it says describe a test you carried out to distinguish between sodium oxide and phosphorus oxide, because that's the product of reaction part A. Well, what I'm going to say is, okay, add water, add litmus paper, and litmus paper is blue if with sodium oxide and red if with phosphorus oxide. So to have crystal structure on silicon dioxide and sulfur trioxide. Silicon dioxide, macromolecular / giant covalent. I say macromolecular. Sulfur trioxide, that's just molecular. We could say simple molecule. Explain why silicon dioxide had melting point sulfur dioxide. Covalent bonds covalent bonds in silicon dioxide, whereas van der Waals forces between molecules in sulfur trioxide, covalent bonds are stronger than van der Waals forces. Covalent bonds require more energy to be broken compared to van der Waals. Oh yeah, compared to van der Waals. Don't want to waffle too much. Right equation of reaction sulfur trioxide, potassium hydroxide, so sulfur trioxide, potassium hydroxide. Now what happens? Okay. Well, the simplest one is KHSO4. Yep. Equation reaction magnesium excess magnesium oxide plus phosphoric acid H3PO4 . How would I do this? What am I going to form? I'm going to form this with this and then water. And how do I know that? Because I know I'm going to form water. And that's why you should memorize at least 2 examples from the textbook so you have a template of what to build up from. Okay, so now I'm going to form water. So if I'm going to form water, these hydrogens are going to react with this oxygen, and therefore I'm going to have Mg bracket PO4. Right, and then it's just balancing. I've got a 3 here, so I need a 3H2O here. But I also therefore need 3 oxygen, so I need a 3 here. And then Mg3PO4 2. What I would recommend is learn these equations extensively, and you still have plenty of time to do that. I haven't even learned a lot of them as well, but I'm still going to focus on learning them as well. And then look for patterns. So then when they give you, oh sorry, I need a 2 here as well. Yep, I need 3 MgO plus 2 H3PO4, Mg3PO4 2 plus 3H2O. So then when they give you unfamiliar examples, you can base them upon. So then write down the examples you do know, and you're like, okay, this is a base plus phosphoric acid H3PO4. I've already learned that example, but not with magnesium oxide. I did it with something else. Then manipulate it with magnesium oxide. Spot the patterns, and then draw a blade formula of undissociated acid form sulfur dioxide reacts with water. Sulfur dioxide reacts with water. Undissociated acid HO SOH and double bond O here. Because think about this, right? Sulfur dioxide SO3 plus H2O H2SO H2SO4, right? But it's the undissociated acid. Okay. No. Oh, days. I'm so sorry. Sulfur dioxide SO2 plus H2O. Well, then you're just going to sulfur dioxide plus H2O, then you're going to form H2SO3. And that's all I've drawn. You don't need any lone pairs, anything. What's the formula of main aluminium containing species of aluminium oxide added to access water? D. Aluminium oxide. The atomic radii of elements decrease across period 3 from sodium to chlorine. Number of protons increases. Hence, the attraction between the nucleus and electrons increases. So I'm multiple sulfur is greater than phosphorus. We're going to talk about the size of the molecule. Molecule bigger than P4 molecules. Is van der Waals forces equals sodium oxide contains O2 minus ions. These O2 minus ions react with water forming OH minus ions. Molecules react phosphorus oxide excess sodium hydroxide solution. Element Y reacts vigorously with water. Oxide dissolved water pH 14. That's very alkaline. Type of bonding, ionic, therefore. Element Y, sodium. And then sodium with water, Na plus H2O to form 2Na plus 2H2O to form 2NaOH plus H2. And if I scroll up, let me just take you guys a bit up. There we go. No. There we go. Same exact equation. 2Na plus 2H2O, 2NaOH aqueous plus H2 gaseous. There's only all these equations I can test you on. And then run equation for reaction with oxide of Y. So sodium oxide with HCl. Where you're going to form NaCl. You're also going to form H2O guaranteed. So you need 2 here, a 2 here, and a 2 here. No, sorry. Reaction of this oxide. No, that's sodium hydroxide. So I need sodium oxide. Na2O plus 2HCl, 2NaCl plus H2O, and that makes sense. Just have bonding is oxide, forms amphoteric oxide, very high melting point, ionic. Write the formula of this amphoteric oxide, Al2O3. Synonym of the term amphoteric, can react with acids and bases, and then this part 4, write 2 equations show amphoteric nature. So it wants you to show one of it reacting with the acid, one of it reacting with the base, and it is Al2O3. Okay, this one's a bit weird because it's not giving us anything with reacting, so you could just say anything. And I guess that's really nice. So you can say Al2O3 plus whatever equations you know in your textbook. So yeah, I'm gonna leave this part out. You guys can use equations learned in textbook. So you should have at least 2 equations in your textbook, one for acid, one for base, and you just use any of them. Yep, don't need to go through that because just recalling your 2 equations. Obviously, a lot of these are, but I don't want to just specify to 2. Whatever equations you guys want to use, you can use for this. So that's why I'm going to leave this out. State where both oxides form alkali solutions. The idea that both contain oxide ions. Both contain oxide ions, but which react with water to form hydroxide ions. And that suggests why sodium oxide from solution with high pH solution formed from magnesium oxide, sodium hydroxide is more soluble than magnesium hydroxide. Remember, with magnesium hydroxide is insoluble in water. I'm pretty sure it is. Let me just double check really quickly. Is magnesium hydroxide insoluble in water? Yeah, it's considered, sparingly soluble, so therefore is almost insoluble in water. So just by memorizing that key fact, which you should have learned, and then therefore you know then therefore because sodium oxide is more soluble than it. Given the equation reaction between phosphorus oxide P4O10 plus water plus 6H12 4H3PO4, and then this one I don't know why this is here because this is transition metals, but yeah, it fits along the theme, I guess, of learning equations. But yeah, the equations V2O5 plus SO2 form V2O4 plus SO3, V2O4 plus a half O2 to form V2O5, V2O5 plus SO2, V2O4 plus SO3, V2O4 plus half O2, V2O5. And again, those are just two equations you just have to memorize. And that is the end of the properties of period 3 elements in the oxides question paper.